Hey guys, welcome to this really quick breakdown of this very simple procedural palm tree that I've made. If we dive inside, you can see if we go to this palm tree node, we have access to some basic controls where we can control the size of the tree and the amount of leaves and also the size of the leaves. I kept this set up as accessible as possible for new users of Houdini. There's lots of very common procedural modeling techniques used throughout, such as the use of vex to randomize and control attributes that are then used during a for each loop and a copy to points to control things such as the rotation of each leaf barb with randomization, and also the shape of the leaf, which you can see through these ramps here on the set attributes wrangle that I've named. You are able to control things such as the leaf angle and the leaf shape as well. This is the leaf. There's nothing too complex going on here, like I said. However, it may be worth just running through the setup now for you. So to begin with, I started off with a line, and then to create the stalk, you can see down here, I've used this labs tool called Curve Sweep, which made this process really simple. If you don't have this node installed, make sure you've got the latest version of Houdini. And then if you go over to the Side Effects Labs shelf, just make sure you hit Update Toolset. So here I'm able to control the shape of the stalk. And then going back to this line, I have resampled it, which gives me the ability to control the amount of leaf barbs that I instance. So if I was to increase this length, you can see we get a smaller amount of leaves, and equally, if I was to increase it, we get more leaves. Next, I've used another line to again use a sweep curve set to line instead this time. So we just get a 2D plane shape. And here I've just roughly done the shape of a leaf. And then, like I said before, we then run it through a transform, which based on these attributes that I set here, it then varies the amount of rotation I add in the X. Moving on, you can see a few of these attrib vops called color. Here we are able to control the color of each leaf. So I've used this curve U attribute throughout, which you can get from this resample node here. If you enable curve U, essentially what that gives us, if you don't know what it is a 0 to 1 float attribute running up the line. And that allows me to then remap it using custom ramps, channel ramps. You can see the curve U attribute here, which I then clamp to these min and max values, which again, I've promoted to these custom parameters that you can control. So if I was to change things such as the max length, we get a bit more random variation. The max bend. Which is being fed into this bend node here. You can see I'm reading in using the point function, this for each begin, which I then look for this bend attribute, which I'm setting here. So here is where I set it to this ramp. You can see just after it, I'm adding a bit of a random increase or decrease in the variable size so that we get a bit of roughness to the amount of bend or size or rotation. So that's a leaf. I know that was a bit vague, but like I said, I recommend you kind of combing through this setup yourself to see how it works. Here I was just experimenting with adding some noise, which I've currently added an offset of $T just to kind of see what some really rough wind may look like on this leaf. This is quite a dirty way of doing wind. However, you can get some decent enough results for this simple setup. Again, going back to this color node, you can see I've used the resample node to set this curve U attribute, and then inside this bot, I'm just simply using some noise, which I can then map to this color ramp that I have. And then I'm multiplying that with this curve U attribute that I have remapped as well to some colors. And then I'm multiplying those random noisy colors to my curve U attribute here, which I'm exporting as color. Next, I've done a very, very simple trunk. So again, we're starting with a line, very tall line, which, once again, using the same 3 nodes, a resample, which lets me control the amount of separation in the points, and also creating this curve U attribute, which is useful for many reasons. Next, I use this curve sweep to get out this really rough profile of a palm tree, which you can see I've really crudely drawn out here with this ramp. You can play around with this, refine it as much as you like. And then I'm adding a bit of random bend to it, because palm trees normally don't go straight up. Next, I'm adding some noise in the surface and also in the color, which you can see here if I dive inside this attrib VOP. At the top are the nodes which I use to displace the geometry position. Basically, I have some noises, which I then feed into this scale attribute of this VOP called displace along normal, which is excellent for this sort of quick, noisy variation. And then remapping curve U again to a custom spline, which you can see here, which I'm using to multiply the amount of displacement that happens, because I wanted the top to be a lot more rough than the rest of the bark. So using this ramp, you can see here I've cranked up the multiplier by 3 times so that we get some more displacement going along the top part of the trunk. Next, I am using another labs tool called Calculate Occlusion, which is great for adding in all the benefits you get from an ambient occlusion pass. And then I am simply just multiplying the color that we get from this displace by the result we get from the Calculate Occlusion. And then simply a normal afterwards, which helps us visualize all that detail we get from the displacement. So feel free to dive inside and improve this noise. You could probably promote a few of these attributes as well using the middle mouse, promote parameter. This is just what I ended up with quickly. That's our trunk. Now we have our leaf and our trunk. We then need to procedurally scatter our leaves around the top. So to do that, I'm starting off with my trunk. I'm then using this really useful color gradient node, which essentially, based on any axis we want, will set an attribute from 0 to 1. Here I've remapped the ramp to only grab the top part of the trunk. If you see I set this back to CD by default, you can see I've only grabbed the top part. I'm setting this instead of the color to be density, and that is because in the scatter node I've enabled the density attribute to be used to control where I scatter these points. So you can see I'm only scattering at the top, and that is because I've remapped this ramp to only be at the top part. Next, I'm getting the whole height of these points, 0 to 1, which I'm then going to use to help control the amount of angle that I set in the palm trees, because the ones lower down I want to be bending further down, and the ones at the top I want to be pointing upwards. So this height attribute will be used later. And then randomly setting the p-scale using these new nodes with a 18.5 called attrib adjust float, which by default is set to p-scale. I've then set it to random and the min and max 2 and 3, which I've then promoted to this node down at the bottom, allowing us to control the p-scale. So that's the p-scale, which controls the size of each leaf. I then set my own custom attribute called up angle, which is currently set to -20 and 20. And up angle is being used in this bend node again, which I am using to bend the leaves as they're instanced. So same setup as you've seen before, using a for each and a copy to points, I am able to use some custom attributes to drive the rotation and the amount of bend that I add to each leaf instance. So the transform, just before the bend, I am simply aligning the leaf to the z-axis, and that is because when we copy to points inside Houdini and or instance, it's always paramount that you align your geometry to the z-axis, because that's what it assumes you've aligned it to. So once I have the leaf aligned by using 19 minus 90 in those values, I can then read in my custom attributes bend and up angle, which I set here by looking at each for each begin, which creates this. And finally, I'm simply adding a time shift just to prevent it from calculating on each frame. Sometimes a good idea just to drop these guys occasionally when you know you want the mesh to be static, just prevents it from cooking unnecessarily. And once again, I'm adding in that really dirty wind, which is simply just a turbulent noise being driven by this curve U. And that is because I do not want the palm tree bases to be moving in the wind, only the top parts. So you can see it starts off at 0, and I'm adding in just a tiny amount of wind right at the end, 0.1. This trail node is being set to compute velocity, and that's going to give us correct motion blur on the deformation of each leaf. And that is our leaves. So the final thing to do is to combine our leaves and our trunk to create our palm tree. You can see just before the merge, I've also dropped down some material sops just to assign a separate material to the leaves, to the trunks. Then I've simply dragged and dropped some of these parameters further up that I thought were useful to have all in one place, such as the base line length and the p-scale and the force total count. Alright, and that is my overview of this very simple setup that I have made to create this procedural palm tree. I'm going to link the HIP file, which I recommend you look through if some of this maybe went over your head or I have skipped parts that you are interested in diving into deeper. Hope you found this useful. Thanks for watching.